There's a 1-point quiz because I figured the observations are probably not going to be that great, most likely. But I might be wrong. You know, the observations can be good. It happens. People. It happened to me when I was a graduate student. I spent 2 months doing a series of experiments, and it was a lot of work. It was hard. Took observations, and then about 2 years later, I had to take that data and write a formal report for it. So I went back through my observations, and I couldn't tell what I did. You know, it made no sense. And since I couldn't tell what I did, I had to go back and repeat 2 months worth of experiments, which was, you know, it was torture because I didn't want to have to do that. But I had to because my observations just sucked, basically. And so there are certain things about that. The one point is observations. Another point is, you know, when we went into this lab, we already had an expectation of what was going to happen. And so there's this famous quote. I don't remember the words exactly, but it goes something like that. That chance favors the prepared mind. Have you ever heard that? Chance favors the prepared mind? I think it's by Pasteur. Pasteur discovered, what did he discover? Was it Pasteur? I forgot. It was, but you know, the discovery of penicillin? You know, that was just by chance. And if the person didn't know, you know, that was an unusual result, then nothing would have ever became of it. You know, they would have just washed the dishes or whatever else. And so, you know, the same thing here with these reactions. You know, did these come out as expected? And I would say, yeah, B probably didn't, because B, what did we predict for B? We predicted a precipitate. Did you get a precipitate in this one? Did anybody get a precipitate? Some people should have gotten a light baby blue precipitate, but what happened to that precipitate? It disappeared. The precipitate disappeared and was replaced by a dark blue solution. And so that's an unusual result, unless you know, do you know what happened? Yeah. And this one, what did you predict? You would predict to form, you know, hydrogen gas, which is a clear colorless gas, and you'd expect the lead to dissolve. But what did you end up getting? You got no reaction for this?
No reaction.
Well, that's wrong. You should have gotten a reaction because we're going from stronger to weaker. This is why I said, this is number 19. This is why I said there's another reaction that happens. So I was thinking, maybe it'll click. There's another reaction that happens when you're making your prediction. And so in this particular one, the lead goes to lead-2 ions and the hydrogen goes to hydrogen gas. The chloride is a spectator, but really, is the chloride a spectator? No, chloride loves, well, you figure it out. And so this one, you're supposed to get a white PPT. And did that happen? Did people get a white? If you didn't get a white PPT, it could be that you just didn't let it react long enough. You know, it might have been a sluggish reaction, but you definitely should have gotten a white PPT, and that would have been unexpected, unless you did the second reaction of part 19, which some of you did, some of you didn't. So I was just curious what happened with that. Okay. Well, speaking of unexpected reactions, let's take a look. Did you guys do the predictions for experiment 17? How many people have completed the predictions for experiment 17? Okay. I was going to demo all of them. You know, the 7 reactions I wanted to demo, but I think what I'll do is I'll wait until more people have finished it. I'm just going to look at one reaction. Well, let's look at 2 reactions. Okay, this is lead acetate. So one thing is, what color is lead acetate?
Clear.
Well, this is a clear colorless solution, and so CCS. But lead acetate itself, you can see some water evaporated. Do you see the white solid there? Lead-2 acetate's a white solid. That's why I'm wearing gloves, because I don't want to touch the lead salt there. Stoppers like this have a little place where you can pinch this between your fingers. And so we're going to pour some lead-2 acetate in this test tube here. The first reaction is lead-2 acetate plus sulfuric acid. Is that what you have? Or sodium carbonate? Okay. Lead-2 acetate plus sodium carbonate. Sodium carbonate. Sodium carbonate, what color is it? Clear, colorless. Clear is, you know, there are people who are gonna say clear is not a color. What color is clear? Yeah, and so people like the word colorless instead. This stopper is totally different. I can't pinch this one between my fingers easily. This stopper is meant to be set on the counter. Now, do you set the stopper like this, or do you set it upside down on the counter? You set it upside down because of cross-contamination. This will pick up whatever. And so we set this on the counter. It should stay clean. And then we're going to add the sodium carbonate to this. And so what color do you predict the precipitate to be?
Blue. No, purple.
Purple precipitate?
It's lead acetate and
Lead 2 acetate and sodium carbonate is going to form lead 2 carbonate, which is black. Well, if this is colorless, you know what I expect the precipitate to be? Colorless. Colorless is also white. You know, if you look, have you ever looked at table salt? Table salt looks what color? White. But have you taken one individual grain of table salt and looked at it? It's clear, right? It's transparent. It's colorless. And so let's take a look. You know, it depends on the crystal size. And we get a white PPT.
Yeah, that's good.
All right, the next reaction we're going to do, and this is the only other one I'm going to do for right now, and then we'll come back to it after you guys have predicted the rest, is lead 2 acetate and sodium hydroxide. Here's what sodium hydroxide. Sodium hydroxide is a common chemical. Common chemicals you don't have to write the observations of. You know, I wouldn't write CCS for sodium hydroxide AQ because everybody should know it's CCS. But for lead 2 acetate, I would write CCS for lead 2 acetate because not everybody knows what lead 2 acetate looks like. Right? Same thing with sulfuric acid. I wouldn't bother writing it down what it looks like. And so I'll get my lead 2 acetate here. And then my sodium hydroxide. The sodium hydroxide, you can see it's spilled all over this. And so this is why they say when you grab a chemical reagent bottle, grab it by the label. Unfortunately, this is 2 labels. So this is why it's 360 all the way around here, because people pour it from different angles. And so I'll just wear gloves and then I get sodium hydroxide. All right, let's see what happens. What color do you think the precipitate is going to be? White. I'd expect it. And that's what it is. It's a white precipitate. You see that?
So we write colorless PPT?
No, white PPT. White PPT. What I'm saying is if you took one of the crystals and looked at it under a microscope, it would be colorless. It just looks white, right? And we can let the precipitate settle to the bottom. You see the white PPT? Is it? Well, maybe it is a clear PPT. The clear PPT. Are you sure? There's probably PPT's there. It's just invisible. And now we call it invisible PPT. This is an invisible PPT.
So if there's no reaction,
You've probably never seen it. So this will be your first time seeing an invisible PPT.
Not because chemistry lab, probably physics class.
Well, you know what that is? That's an unusual result, right? You know what happened here? What happened here is the same thing that happened here. You might have started off with a baby blue PPT. That baby blue PPT disappeared. Why? You know, that's what we got to figure out. And the same thing here. Why did the lead 2 hydroxide disappear? Because I shook it up. You're right. By shaking this, I can make the precipitate disappear. You know, I can make it reappear if I just add some more lead. And so we can get the precipitate to reappear. I'll get the precipitate to reappear, but you know, this PPT you'll start to disappear again. And I shouldn't do it over my computer. I don't want lead on my computer, but otherwise I'll have to wear gloves all the time typing into my computer. But the precipitate is, again, it's disappearing. So what's happening here is, remember the reaction we had between, we had a reaction between silver nitrate and iron 2 sulfate? And I asked you to write 2 reactions for that. Do you guys remember that? This was another one I was going to put up here, but I was going to talk about it. It was this reaction. FeSO4 plus AgNO3. There are 2 reactions for this. Remember that?
Yes.
One would form silver sulfate. The other forms... So which one? Which one happened? Was it the one that formed silver sulfate? That happened? Or was it the one that formed silver metal? That happened.
Silver metal.
It was silver metal? Well, this morning they told me it was silver sulfate. You sure?
I spoke to some of the students in that class and they don't know that problem.
Oh, okay. That explains it.
If it was silver metal, you would be able to see it.
Well, silver sulfate you could see too. It's a white PPT. Did you get a white PPT or did you get a black?
Can't get anything else.
Oh, you weren't here. So keep your mouth shut. We need educated guesses, not uneducated guesses. No, just
You know
joking.
what where it's called making the mirror?
Silver mirror?
Yeah.
Yeah, the problem is that making the silver mirror isn't so easy. Silver, you know what silver likes to do? It forms needle dendritic crystals. Have you seen them under a microscope? They look like little trees growing out here, and they form a fuzz. It looks like a fur, a black fur, when they grow dendritically. To make them grow on the surface has to be very clean, and then you have to grow very, very tiny crystals. If you grow big crystals like that, you're going to get this fur, black fur. The black fur is eventually going to turn silver as it gets thicker and thicker. I don't know what you guys saw. It depends on how long you do these observations for. Well, anyway, so that was a competing reaction. What happens here is there's a competing reaction here as well. There's one reaction that forms the hot hydroxide. The other reaction is a type of reaction we haven't discussed yet. Well, if it's a type of reaction we haven't discussed, didn't we discuss all the types of reactions? What were the types of reactions? Metathesis, acid-base, and redox. So that's it. And we considered all 3, right? Well, we didn't. You know which one we skipped? Can you tell me what reaction we skipped analyzing for? I'll tell you what reaction we skipped analyzing. We did not analyze this for Lewis acid-base reactions. Do you remember us doing Lewis acid-base reactions, CO2 in water and calcium hydroxide in water? A long time ago. Yeah, we didn't do Lewis acid-base reactions because Lewis acid-base reactions are more difficult. And so Lewis acid-base reactions are going to be discussed in Chem 1B. And so in Chem 1A, we didn't even consider that possibility. We should have, because that's the same reason. That lead hydroxide precipitate disappeared because of a competing Lewis acid-base reaction. And so we have to watch out for that.
Would that be the same? Will the same go for that one?
No. No, this one we had a metathesis VS redox. In the morning, the metathesis won. In the afternoon lab, you guys, the redox seems to have won. Actually, both happen. Depends on what time you observe it at. The metathesis is faster. And so initially what people see is a white precipitate. Eventually that white precipitate is replaced by black. There are other reasons why that white precipitate might be, because silver chloride itself is light sensitive, as are a lot of silver compounds. Silver nitrate, any light sensitive compound is not stored in a colorless bottle. Any light sensitive compound is stored in an amber or a bottle no light can penetrate.
So is mercury is light sensitive?
Mercury's not light sensitive.
Because it wasn't amber.
That's because they ran out of colorless bottles, and
Oh,
that's
okay.
what they had on the shelf, so they just grabbed it off the shelf. But if you look at hydrogen peroxide, you know, hydrogen peroxide is stored in a brown bottle. The brown bottle's protected from light. Iodine is stored in the brown bottle. Sodium chloride stored under a brown bottle, but they probably just wanted a brown bottle instead of a colorless bottle for the sodium chloride because sodium chloride there's no light sensitivity for sodium chloride.
Yeah, tips.
But for sure, certain things are light sensitive, so you need to store it in a certain type of bottle. But anyway, that's it about observations. So when we're taking down our observations for experiments like this, we got to think about if you 2 years later, if you're about to write the report for this, will it be clear? You know, if you're writing the report like the day of or a week after, then no big deal. You know, you remember most of the stuff. But 2 years later, you don't remember anything. Absolutely nothing. This is why I asked you to write the procedure down there too, in addition to the observation, so you can make that connection between the procedure and the observation. A lot of people just write these certain random observations there. It's hard to make that connection, especially with time. Okay. And so, don't worry about this. I just wanted to see, you know, what people's observations were and what the level is. But this is just supposed to be a learning experience for this. All right. So, what are we doing today? Well, let's take a break and then we'll talk about today's lab.